Hi students, welcome to today's class. Today's topic is addressing modes of 8051. Okay, so addressing mode is nothing but the way how the operands are addressing or we are dealing with in an instruction is discussed here. The way in which operands are specified in the instruction for accessing the data is called addressing mode. Okay, this addressing mode of 8051 is an important topic in module 2. Okay, an addressing mode is a way to locate the target data. It's also called operand. Okay, now 8051 microcontroller supports the 5 addressing mode for addressing the operands. So addressing modes is nothing but in order to address the operands. So there are different operands, that is move A comma B. So A and B are operands. So how these A and B or the operands can be addressed in different ways. So here we are discussing the different ways of addressing the operands. So there are 5 ways of addressing. That is, first one is immediate addressing mode, second one is register addressing mode, third is direct addressing mode, fourth is indirect addressing mode, and fifth is indexed addressing mode. Okay, so we want to study each one, the definition of each one and an example for that. So moving to the first addressing mode, that is immediate addressing mode. So from the name itself it is clear that immediate addressing mode. So we want to immediately take the data. So in order to take the data immediately, we want to take the data itself. Okay, so in this addressing mode, data is specified in the instruction itself. So that data is specified in the instruction itself. Okay, in this case, operand itself is the data. The symbol hash before the data indicates that it's a data and not an address location. Okay, so we know that move A comma 50, which means that 50 is an address, A is a register, that is 50 address is moving to A. So here in direct addressing mode, we are giving the direct data, move hash 50 comma A, which means that this is not an address, this is a data. So we move the 50, the number 50 to A. So this is called the immediate addressing mode. So we are using an hash icon before the number. Okay, so this is an example for immediate addressing mode. So here add A comma hash 20. So in immediate addressing mode, in order to separate it is a data and it's not an address, we want to use hash. So hash means here it is the number 20. So which means that the data in A, that is an accumulator, A data is added with a number 20. This is add A comma hash 20. Add 20 decimal to A and store in A implies A plus value. So a 20 decimal value is added to A and the result is stored in A. So this is add A comma hash 20. This is immediate addressing mode. So immediately we are taking data. Okay. So move A comma hash 20, which means that the data 20 or the value 20 is moving to the register accumulator A. Move DPTR. DPTR is a 16-bit register. This A is 8-bit register. That is 100, 1000, hash 1000 is moving to the data pointer. Okay. So this is about immediate addressing mode. The second addressing mode is register addressing mode. In this addressing mode, data is specified by a register in the instruction. So here we are not using the data directly. Here we are using a register. So that's the name itself, register addressing mode. So here we are using a register. So the data is stored in the register and the register is calling. Okay. In the case of register addressing mode, one of the operand must be accumulator and other operands must be any R0 to R7. So in register addressing mode, so we are using two registers. Okay, register addressing mode, we are using two registers. So the one register should be accumulator. So this is destination and this is source value. So this source is moving from here to here. This is destination. So A can occupy either destination or source position. It doesn't matter. But the only important thing is that we should use either. that is an accumulator register, because we are dealing with two registers, that is register addressing mode. Here move A comma R0 means this is source position, this is destination position. So the data in R0, so R0 is a register, so in the register maybe we have, that is move R0 comma hash 30. So the register have the value 30. So move A comma R0 means the value in the register which is 30 is moved to A. So this is copies the value of content of register R0 to A. So we are looking the R0 content and it is copied to A. So move R1 comma A means the data in A is moved to the register R1. Okay. So this is register addressing mode. Both the operands can't be registers, that is opcode are limited. These R0 and R4. So here we are not using an accumulator. So this is invalid instruction. So when we are using register addressing mode, we are using two registers. So one should be an accumulator. Okay, that is register addressing mode. Hope you are understand this. Okay. Then the third addressing mode is direct addressing mode. So the name itself, it is clear, direct addressing mode. Here we are giving address directly in the opcode. In this addressing mode, address of the data are operand in the instruction. Using direct addressing mode, we can access any register or on-chip variable. This include internal RAM 00 to 7F or special function registers to 80H to 0FF. Okay, so here direct addressing mode. So instead of giving a register, here we are giving a direct address. So this is address. Okay, so we are not given hash here. So it is an address. So the data in this address. So there is an address 20. It have a data 50. Okay, so this is an address. This is address and this is data. So this address have a data 50. So move A comma 20 means the this instruction will go to the address location 20. So this is the address location 20 and the data in this location is moving to the accumulator. That is move A comma 20. The data in the address 20 is moved to the accumulator register A. A gets the content of RAM location 20H. Move 20H comma A. It's nothing but the data in the A is moving to 20H. Okay. Okay, so 20H location. So here we have 20H is the location of 20 have 50 data. So inside the A we have a 10. The data inside A is 10. So the data in A is moving to the address. So it is overwritten and the address 20 will have the 10 as that is data in A. So this is move 20H comma A means the data in accumulator will move to the address 20H. Then move 20H comma R1 means the data in R1 is moved to the address 20H. Move R1 comma 20H means the data in the address 20H moved to the R1 register. Here move 20H comma hash 20 means the data 20, the 20 data, it's itself a data, the value 20 is moved to the register 20H. So there is a register 20H. Okay, so sorry, it is the address location 20H. So the data 20 is moved to this location. So the 20 H address has the data 20H. Okay, so this is data hash. Move 21H comma 20H, which means that there is a location named 20. This data is 10 and there is another location 21H. Okay, which means that the data from 20H is moved to 21H. So data from 20H is 10, which is moved to 21H. So this is address to address movement. Okay, so that's all about direct addressing mode. Okay, then next is an important addressing mode, that is indirect addressing mode. It's also called register indirect addressing mode. In this addressing mode, the address of the operand is specified as the content of the register. Here we are calling the content of the register is nothing but the address. If we given any data, any value to a register, if we call the register, then it uses the content as the address. Okay. The @ symbol indicates that the addressing mode in indirect. So indirect addressing mode is indicated by the the symbol at. Okay. Then next is, now we have two types of indirect addressing mode. That is indirect addressing for internal RAM and indirect addressing for external RAM. If we take the data from internal RAM, we are using this type of addressing mode, indirect addressing mode. If it is using from external RAM, we have used another type. Okay, so in the case of indirect addressing mode, the operand used in instruction contain the internal RAM address of the required data. This addressing use only two registers R0 and R1 as pointers. So these registers are also known as data pointer. So in indirect register mode, we only use two registers, that is R0 and R1. Of course we use accumulator. Along with accumulator, we only use R0 and R1. It's also important. Indirect addressing mode, we are using the registers R0 and R1. Okay, so first example is R0, comma, #20. Okay, this is a step in this. This is indirect addressing mode. A, comma, @20. So before that, we want to move R0, comma, #20, which means that #20 is a data. So the data is there in R0. So we have R0 has a data 20H. This is the data. So R0 is a register which has a data 20H. Okay, now move A, comma, at R0. At symbol indicates it's a indirect addressing mode. Move A, comma, at R0 means move the data in R0 to A, right? So how we are calculating? Move R0 to A. So A we have R0. So we are looking R0. R0 we have a content 20. So we are not taking this content. We are taking the content will become address. Then we are taking, there is a address 20 and it has a value 15. Okay. So then in R0 we have a content 20. Though this data is converted as address, then this move to this address 20 address and take the data 15 here. So here we A have 15 as the data. So this is indirect addressing mode, which means it is not working in a direct way. It is working as an indirect way. So this move A, comma, at R0 means that here A is not taking the data at R0. The A is considering the taking the data in the R0 as an address. Okay, it is considered as an address. This data as an address and it will move to that address and that data in that address is taken and is moved to A. Okay, move the content of the internal RAM address pointed by R0 to the accumulator. Okay, so indirectly implies A 20H. That is, A take the value of address 20H. Here, move R0, comma, #20 means #20 value is given to R0. So R0 is a register which has a value 20H. Now move A, comma, R0. Then what is simply doing? R0 have a value 20H. Now A take the register 20H. Okay, so it's simply A takes the value of register 20, not the address location 20H. So here A copies not the 20H, that is the data in the 20H. So it is called indirect addressing mode. Okay, in this case, move at R1, comma, A. Here the data in A move to the address of R1, that content of R1 address, the copy is moved to that address. That is, we have A equal to 50. Okay, so move A, comma, at R1, comma, A means the content 50 is moving to R1. R1 have a content 112. R1 have a content 12. So the 50 data is moving to the location 12. So there is a location 12 which is vacant. Then this 50 is moving to the content of 12 is converted to the address location and the 50 is stored on this location, that is content of R. Okay, so this is called indirect addressing mode. Move at R0 #20. So #20 means a data. This data is moved to the R0, not the R0 value. There is R0, there will be a data that is maybe 50H. So this data is converted as address, then this 20H is saved in the address location 50, not R0. The data in R0 is converted as an address location and this data is moved to that address location. So it is called indirect addressing mode. Okay, this is in the case of internal RAM. Okay, if the indirect addressing mode occur in external RAM, what will happen? In case of indirect addressing mode is accessed from external RAM using R0, R1 and data pointer. So in indirect mode, we are using only two registers R0 and R1. In indirect mode, external RAM, we are using R0, R1 and DPTR. So the only difference is that if we are using external RAM, instead of move, we have MOVX. Okay, in internal RAM, we have this only move, but in case of external RAM we have move X. Okay, so here R0 R1 can address up to 256 location because R0 and R1 is 8-bit address and data pointer is 16-bit address, so it can access location 64K. Move X is normally used for external RAM. IO address and input output address. Okay, all external moves must involve the A register. So it should have A register. Okay, along with A register, it may have R0, R1 and data pointer. So in order to identify it's an external RAM, we are using MOVX. So MOVX A comma at data pointer means at the register data pointer there will be a data. So convert that data to an address, then take the data in that address and it is moved to A. Then similar case, move A comma at R0 means there is a R0 register which has a content. That content is converted to address, then move to that address and take the content of that address and move to A. Then here MOVX at data pointer A means A is moved to the content of data pointer location, that is address location. Okay, then move at R1 is similar. The A data is moved to the R1 register which has a content that is 15. So that A content will move to the address of 15 location. So A is stored in the address 15. Okay, so this is about indirect addressing mode. So we have discussed indirect addressing mode in internal RAM and external RAM. In case of internal RAM, we are using only move. In case of external RAM, we are using MOVX. So since it is indirect, we are using at. In internal RAM, we are using R0 and R1 and A as register. In external RAM, we are using R0, R1, A and data pointed as registers. Okay. Now we have the last addressing mode is indexed addressing mode. In this addressing mode, data is accessed from code memory using A and data pointer. Addressing mode data accessed from code memory using A, PC and data point register. Here we are using A register, PC register and data pointer. Here we are only using these two registers. A, PC means program counter and data pointer. It is indexed addressing mode. This is indexing something. Okay. Internal or external ROM contains permanent data which is stored in the form of lookup table. To access a lookup table, then this addressing mode is used. To access any lookup table, we are using this address mode, that is indexed addressing mode. So mainly the application of indexed addressing mode is in the lookup table. So we have already studied what is lookup table in the interrupt of 8051. Okay. With indexed addressing mode, the effective address of the operand is the sum of base register and an offset register. Is nothing but there is an effective address. So we are using there will be one effective address, that will be A. So effective address will be A. Then we are using the sum of two registers, that is base register and a offset register. So this is the case of indexed addressing mode. So we are using A register. Along with A register, we are using add a sum of base register and offset register. Here offset register is accumulator A and base register either data point DPTR or program counter PC. So this is the case of indexed addressing mode. So the indexed addressing mode, for example, move C is used in indexed addressing mode. Move C. Okay. So move C, A should be the A comma sum of base register and offset register. So the base register, the offset register should have at symbol. Okay, so at A plus DPTR. So these are the two example of indexed addressing mode. Move C A comma at A plus DPTR, or move C A comma at A plus PC. So these two values will be changed. It may be DPTR or maybe PC. So the content of ROM address pointed by A plus DPTR. So this is the ROM address, that is A plus DPTR. This content will move to the accumulator. So the content of A plus PC is moved to the content. So this is A plus PC. There is an A plus PC. Then its content will be an address. Then the address of then that address will in, uh, indexed with a data. That data is moved to A. So move the content of the address point by A plus PC. So thus we add A accumulator with a PC. There is an A plus PC. So take the location A plus PC. Then its content is converted at address. That address, the content of that address is given to A register. So this is the indexed addressing mode. Index addressing mode, we use a offset, sum of offset address and a base address. The base address may be data pointer or PC. The offset address will always be a accumulator, and there should be a there should be a base register, that is A. So move C A comma at A plus data pointer, or move C A comma at A plus PC. So this is about indexed addressing mode. So that's all about today's class, that is addressing mode of 8051. Thank you.